Hello guys, you're welcome to today's episode with Courage Online Math Class. On this video lesson, we'll be talking about a very important topic which is known as waves. So, we have to know what is a wave, the definition. So, we have right now on the board, what is a wave? A wave is very simple. Just pay attention. A wave is a disturbance. That must be noted. A wave is a disturbance. Is a disturbance. Is a disturbance that travels to a medium. That means that travels through a media, thereby transferring energy. So for the next part, transferring energy from one point to another. From one point to another. That is not all about. That's not what I'm talking about. The nature of wave. It still continues. So let's see the first statement. A wave is a disturbance that travels through a media, transferring energy from one point to another without causing a permanent displacement of the media. That means without causing a permanent displacement of the media. That must be noted. So let's read the definition. A wave is a disturbance that travels through a media, transferring energy from one point to another without causing a permanent. This must be noted. A permanent displacement of the media. This must be noted. That a wave is a disturbance that travels through a media. That means if there's no media, a wave cannot occur. That means it must transfer energy from one point to another without causing a. That means that without causing a permanent displacement of the media, means that the media is not moving permanently. It's for a temporary time. So this is the definition of a wave. So this was noted that the motion. You have to find the motion. The motion of a wave is vibratory or oscillatory. So this is the motion. It must know that this is the motion of a wave. In motion, let me define motion. Motion is the change of state of a body, and we have four types of motion. We have transition motion, oscillatory motion, rotational motion, and circular motion. So in terms of wave, it has vibratory motion or oscillatory motion. That must be noted. So let's take on the classification of wave. Let's look on the classification of waves. On the first one, mechanical waves. So this must be noted. These are waves. So these are waves. These are waves. These are waves that requires. So that requires a material that requires a material media for their propagation. That must be noted. Propagation. So, consider that mechanical waves, these are waves that requires a material medium for the propagation. That means that if there's no material medium, mechanical wave cannot occur. So let's take examples. So that examples are, number one, a good example, number one is sound waves. These sound waves travels faster in solid. That means that travel faster in solid, liquid, and gas. That means that sound waves travel faster in solid than liquid, and also travel faster in liquid than gas. That means that the rate at which sound waves travels increase to this side from gas to solid, while the rate at which solid or which sound wave decreases is this way. That means it increases from gas to solid while it decreases. So it decreases. From solid to gas. Okay, let's take another example. A good example also of mechanical waves that we have is water waves. So another example is water waves. So these are the two good examples of mechanical waves. Remember I said that mechanical waves are waves that requires a material medium for propagation. That must be noted. So let's take number two difference. Number two on electromagnetic wave, because we have four types of classification of waves. So let's take electromagnetic wave. Okay guys, this number two on classification of waves, electromagnetic waves. So this was admitted that electromagnetic waves are waves that do not require a material medium, unlike mechanical waves that require the material medium for propagation. This one they do not require. Oh, these are waves that travel through a vacuum. So can say that these are waves that do not require a material medium for their propagation. This must be noted. So electromagnetic waves, these are waves that do not require material medium for the propagation. So we have good examples, e.g. examples are, we have gamma rays, we have radio waves, and the rest. So I'll give you an acronym on how to remember all your electromagnetic waves. The acronym is rabbit, meet, in, very, unusual, expensive, garden. So rabbit meat in very expensive, very unusual expensive garden. So this must mean that it can be deduced or it can be inferred that the first symbol of the set, that means we take this arrow, we take this M, we take this I, we take this V, we take this U, but on expensive we don't take the E, we take the next letter which is X, then we take this G. This first letter of the words making it a sentence are acronyms to remember your examples of electromagnetic wave. For the first one is radio. That means arrow stand for radio waves. So radio waves. For the second one, M stand for micro waves. For the third one, I stand for infrared waves. So then over to the next one, which is V. V stands for visible light. So visible light waves. Then for this usual, which is U here, U stands for ultraviolet. So ultraviolet waves. Then for this expensive, take the S, not the E. Remember, take the S, not the E. S stands for X-rays. So it will be X-rays waves. Then for this garden, which is the last one, is gamma. So this G stands for gamma rays waves. So it will be, let's take it here, it will be gamma rays waves. This was noted that the acronym to remember all your electromagnetic waves is rabbit meat in very unusual expensive garden. For the first one, take the first letter which is arrow, means radio waves. Second one, M, mate, means microwaves. Second one, I, infrared, which is very, stand for visible light rays. Then usual, which is U, stand for ultraviolet rays. E, which don't take it, take the S. I remember, take the S, not the E. S stand for X-rays. While garden stand for gamma rays. This must be noted that these are the examples of electromagnetic waves. So let's take number 3 on longitudinal waves, on classification of waves. These longitudinal waves, this may noted that longitudinal waves are waves which direction propagation are parallel to the direction of vibration of the media. So let me write it in the board. So these are waves. These are waves. These are waves which direction of propagation are parallel. The keyword here is parallel. So it must know that the keyword here is parallel to the direction of vibration of the media. So longitudinal waves are waves which direction propagation are parallel. To note the word parallel is needed in the answer to the question. Parallel must be noted to the direction of vibration of the media. So there are examples of longitudinal waves as we have earlier on electromagnetic wave and mechanical waves. There are examples. So example of longitudinal waves are good example are sound waves. So example is sound waves. And it must be noted that the speed of longitudinal waves in fluid, and it has a formula. And noted that the formula is V equals root Bragg modulus over density. So this V stands for your velocity. This V stands for your Bragg modulus. So Bragg modulus. So your B stands for Bragg modulus. While this one stands for your density. You know that this one stands for your density. So your V is your velocity, or can be called speed. Stands for your Bragg modulus, stands for your density. It must know that this is the formula for the speed of longitudinal wave in fluid. So let's take number 4, classification of waves. Is transverse wave. Transverse can be defined. These are waves which direction of propagation are perpendicular, unlike longitudinal wave which they were parallel. When I say A and B are perpendicular, that means they're in a right angle form. So I said that from this one, first waves are waves which direction of propagation is perpendicular to the direction of vibration of the media. So whatever say that transverse waves are waves which direction of propagation is perpendicular to the direction of vibration of the media. So we have some examples. Examples are, number 1, we have electromagnetic waves. That means that an electromagnetic wave is an example of transverse wave. I gave you earlier the list of electromagnetic wave. So this must be noted that electromagnetic waves are transverse wave, but not all transverse wave are electromagnetic wave. I repeat, electromagnetic waves are transverse waves, but not all transverse waves are electromagnetic waves. So let's take another example. We have wave on a spring. Wave on a spring is an example of transverse wave. So let's take some questions pertaining to this video lesson on what we have discussed so far. This is question 1 on questions under what we have treated in this video lesson. We have that which of the following is not true about waves. That means what do not contain about the characteristics of a wave. The first one, we have waves transfer energy from one place to another. From the definition I gave earlier on waves, I said that waves is a disturbance that travels from one point to another where it transfers energy. So it travels from one place to another. That means number 1 is correct. That's A is correct from the definition of wave. Number 2, electromagnetic wave have the same velocity in the same medium. That means electromagnetic waves, all the electromagnetic we have radio, infrared, we have visible spectrum, we have X-rays. So they all have the same velocity. That means B is correct. So number C, particles of a media vibrate if there is a wave motion in the media. I told you earlier that it was noted that waves undergo vibration or oscillation motion. That means option C is correct. While number D, the velocity of a sound wave depends on the temperature. That means for it to occur, the velocity must depend on the temperature for a wave to occur. That means D is correct. Let's move on to E. How waves requires a material medium for propagation? This is very wrong because I told you that mechanical waves are waves that requires a media, but electromagnetic wave does not require. That means option E is totally wrong. That means from the question, which of the following is not true about it? That means option E is the answer to this question, because not all waves require. Some don't require material medium, while some requires. So let's take question 2. Guys, this question 2. Well, which of the following is true of light and sound waves? We have number 1, they both transmit energy. That means light and sound waves, they are waves, and it's a general catalytic for all waves to transfer energy. So we are correct. So this number A is correct. Let's wait. B, they both need a material medium. No. Sound waves is mechanical. It requires a material medium, but light waves does not require. So B is totally wrong. For C, they are both transverse waves. Transverse waves are electromagnetic waves. That means light is among. That means light is an electromagnetic wave, but sound is the mechanical wave. So option C is wrong. Their velocities in air is equal. It cannot be equal because light wave is electromagnetic, while sound wave is mechanical. So they can't have the same velocity. So we'll go for option A. So A is the answer to this question. So let's take the last question on this video lecture. Question 3. I read the question. Which of the following types of wave requires a medium for propagation? I told you earlier that mechanical waves are waves that require a material medium for the propagation. That means to say that for waves to require a material medium, it must be mechanical. So option A, we have radio wave. Radio wave is a good example of electromagnetic wave, so A cannot be the answer. B, we have X-rays. X-rays is another good example of electromagnetic wave. B cannot be the answer. We have D. Let's leave C first. D, we have light rays. Light rays is a good example of electromagnetic wave. Cannot be the answer. Then we have C, sound waves. Sound waves are good examples of mechanical. I stated earlier that mechanical waves are waves that require material for propagation. So C is the answer to this question, which is option C. So if you enjoy what you watch throughout this video lesson, do not hit the subscribe button for more content, and want to like, comment, share to your friends who find it very difficult and want to improve their style of physics. Thanks for watching throughout the video lesson.